Today we are going to discuss something on success of for prophylactics and therapeutics. Let me go into the discussions. First one, what is shrimp farming? As we all know, shrimp farming is farming of aquatic organisms, especially shrimps, under controlled environmental conditions. So, as far as shrimp farming is concerned, shrimp farming is actually classified as a high risk, high reward business because the risk associated with the business is also high. At the same time, the reward associated with the business is also high. So, shrimp farming is high risk, high reward business. The main risk of shrimp farming is disease. There are the two modes that which this disease can enter into the system. One is via natural act, and another one is poor management practices. So it is also known as PMP. So the act of natures cannot be controlled, but via better management practices, we can control the diseases to maximum possible extent. So the removal of stress is the best strategy of successful shrimp farming. So let me clarify what is prophylactics and what is therapeutics. Prophylactics is a preventive medication, while therapeutic is curative medication. Like it is a pre-disease strategy, that is a post-disease strategy. So, like vaccination, immunostimulation, these all are prophylactic measures, while therapeutics are use of antibiotics. So, when the before the disease has occurred, we have to provide the specific preventive methods in order to reduce the possibility of disease entering into the system. So, such practices are called as prophylactics. Once the disease entered into the system, what are all the methods we are employing to kill the pathogen is called as therapeutics. So as per the common golden rule, the prevention is always better than cure. So we have to focus more on prophylactics than therapeutics. So let me discuss something on prophylactics. So first of all, we have to understand the health of soil. There are the types, what are all the possibilities and what are all the sources we are getting the diseases and how we are managing to get rid of diseases or reduces the impact of diseases. I will go by step into the clear aquaculture practices so that we can get idea about what are all the prophylactics working together to form the better and a safe workplace. First of all, understanding the health of soil is as aquaculture is relationship between the soil and water along with the streams or along with any aquatic organisms. So these three components are the essential component of an aquaculture systems. One is soil, another one is water, and another one is animal. If three are in an equilibrium, there will be the best strategy we can follow. So understanding the health of soil, first one is identify the nature of the previous crop. If the nature of the crop in the previous time was whether it is infected or healthy. So we have to ensure whether it is infected crop or a healthy crop. Next one is identify the types of soil. Muddy soil as a sandy soil. Muddy soil is having the problem with low solubility because when the animal molts, the mud will be accumulated in the body of the animal. It leads to the lucian formation, subsequent survival loss. But in case of sandy soil, especially in the coastal soils, and there will be no much issues and there will be no much turbidity. So the animal will be always in a safer side as well as the survival of the animals will also be increased. And that one is the identity of nature of water retention. There is no seepage loss, there will be no seepage loss. Sandy soil is definitely having a seepage loss. But still, such seepage loss is essential in order to replenish the new water. But at the same time, such seepage losses also leads to the disease spreading to the nearby ponds. So, and the fourth point is soil quality parameters, especially soil pH and organic carbon content. If the previous crop, if the previous crop was highly intensive farming, there will be more organic matter left to form in the pond. So before starting the new culture, we have to ensure that the organic carbon content will be less than 3%. And the soil pH as recommended 7.5 to 8.5 is better one. So 7.5 to 8. Because more than 8 is also dangerous. And coming to the nature of water. First, we have to identify the salinity of water. What type of soil water we are using, whether it is a fresh water or brackish water or seawater. In case of fresh water, the definition of shrimp farming, it's not a common definition of aquaculture, it's a definition of shrimp farming. From 0 to 9 ppd is a freshwater site, 10 to 30 ppd is a brackish water site, more than 30 ppd is a seawater site. And identify the source of water, whether we are drawing water from the sea or creek or river or lake. So it's surface soils. So surface waters or open waters. And next you coming to the subsurface waters. It means it's a groundwater. Generally, the open waters are not much safe because it is having the reservoir of diseases. Lot of diseases are occurring in open waters when compared to groundwaters. Yes, the bore waters are the best source for aquaculture because it is sterile. It need not be treated much, and disease outbreaks are also less. So we recommend to follow groundwater protocols for mushroom farming and identify the season. Which season we are actually going for a crop. In summer crop, from February to June, we have to follow the different strategies. In winter crop, we have to follow the different strategies. And identify the water quality parameters of source water. Yes, water quality parameters of source water is also the major problem because when you are drawing the groundwater ionic profile will not be much suitable for the shrimp farming. So we need to alter the ionic profile of the ponds, water, as well and alkalinity, water hardness, and other toxic components such as iron content, ammonia content, as well as hydrogen sulfide content. So we have to understand what our soil is, what our water is. If you are having such ideologies in this thing, we can go forward. Otherwise, we have to again come to the stage. We have to learn all these things, and again we have to go. So if you understand the soil, we have to go for preparation. First, there will be adequate crop holiday between the crops. Yes, majority of farmers who are not following the proper crop holidays, either they are under drying or they are over drying. Over drying may also lead to leaching or loss of nutrients, while under drying may lead to excessive organic carbon left in the ponds, as well as if the previous crop is infected, the same pathogens may also left in the ponds. So we are recommending 21 days to 45 days as the ideal crop holidays. And we have to go for liming of pond because to adjust the pH adjustments as well as mineralization of soil. And we have to go for flowing. Flowing will also lead to exposure of the subsurface soils below the surface to the top layer, so that all the toxic gases bound by the soil will be released into the atmosphere. In case of the EHP affected ponds, EHP is a pathogen which is common in shrimp farming industries. In case of the previous crop was affected by the EHP, there will be the spores left in the pond that can be stay longer for more generations. So that time we have to go for the bleaching and PP compared application. PP means potassium permanganate or 3% Eruvaka application. These both are recommended, but highly recommended is bleaching plus PP compared application in the bottom side. So you can see that is excessive of organic components in the middle of the ponds. And here you can see from the nearby pond, there will be some seepage. Here it's a liming, here it's a so we are understanding the soil, so we are treating the soil accordingly. When we are understanding this water, we have to treat the water accordingly. First of all, the treatment of source water contains two processes. One is sedimentation process and another one is disinfection process. Sedimentation includes the deposition of the total suspended solids and the total dissolved solids, while disinfection includes killing of all the pathogens and the pests of interest in coming into the systems. In case of sedimentation, there are two methods we are following. One is a physical method and another one is a chemical. Physical methods include filtration via mesh and the settlement tanks. We have to pump the water into the one settlement tank. We have to keep it undisturbed for 12 to 24 hours. All the suspended solids will be deposited, and we have to pump the top water. So that will lead to the control of total suspended solids. In case of the chemical methods, we have to employ polyaluminum chloride at 5 ppm dose. It controls the dissolved solids. Coming to the disinfection point of view, we have to go for the bleaching powder disinfection at 40 ppm of 65% chlorine content. It means it's nearly around 250 kg per acre. Or sometimes the people also use FPP, but we recommend bleaching powder disinfection 40 ppm of 65% chlorine. In case of the subsurface waters like bore water, there is no need of any disinfectant and any sedimentations because generally they are free of solids and pathogens. If there is a problem, if you are observing some sedimentation in the turbidity in the bore water itself, we can go for the physical or chemical methods. as per our need. So this is a mesh for water filtration. And here we are at the down, we are seeing bleaching of water. Okay, once the water is highly sterile and there is no sediments, there will be no pathogens. We are getting water into the pond. In the pond, we are going for amendments of water quality because the water as a raw cannot be utilized for any aquaculture practices. So we need to adjust some of the water quality parameters to suit the aquaculture practices. So what are all the adjustments we have to do? First one is ionic profile. Yes, especially in the groundwater, because the ionic profile of the groundwater will be extremely varied. The recommended calcium, magnesium, and potassium. These three components are the major components of the ionic profile. So 1:3:1 is a recommended. But in case of the groundwater, we can see 1:1:2 sometimes. All are in equal proportions. Our calcium will be in higher positions and other magnesium and potassium are in lower positions. So such possibilities are also there. So in order to get a better growth without any stress, we have to balance the ionic profile. By adjustment of magnesium using magnesium chloride, adjustment of calcium using potassium chloride. In case of the excessive calcium, like if the calcium is more higher, we can't able to increase the magnesium to that much extent. So what is the alternative and the best strategy is we have to add the same quantity of magnesium in the feed of that, so that it will be added in feed separately. So that there will be no problems, such as the survival loss, RMS, and nutritional. This ionic profile is a most important component if the farmers are following the low salinization form, especially less than 9 ppt of salinity. And in case of alkalinity is a major problem in low pH ponds, especially during rainy seasons. It leads to pH fluctuation as well as alkyl crash. So recommended total alkalinity level is around 150 to 250 mg per liter. If there is a lower alkalinity, we can increase via sodium bicarbonate or alkalinide. In case of reduction of alkalinity, there is no practical solution. And as per practical point of view, there will be no problem with higher alkalinity because there are some farming communities who are doing alkalinity at 400 or 500 ppm of alkalinity. So higher alkalinity is not a major concern. We have to be more cautious about the lower alkalinity, less than 150 ppm. Yes, there will be severe loss of survival and there will be more severe consequences. And the hardness, especially groundwater, is EDTA application at 5 kg per liter. And it is also no efficient in high salinity ponds. Toxic gases, either we can go for the probiotics. The probiotics are nothing but beneficial microorganisms, or we can go for the chemical treatments. Probiotics are the biological treatment, while if you are going for the chemical treatments, you can use for zeolite. But the zeolite is no efficient in high saline ponds because high saline ponds are having more amount of calcium and magnesium, as I already mentioned. So zeolite works on the principle of the cation exchange. It will releases the aluminium into water and absorb the ammonia because ammonia is a toxic compound. But in case of the calcium and magnesium are there, it will rather than attaching to the ammonia, it will attach to the calcium and magnesium and it will precipitate in the water. So our purpose is failed. So the zeolite is not a good option for the low high saline ponds. The next one is fertilization of water. Once all the water quality parameters are adjusted to the requirements, we have to go for the fertilization of water. There are the two major natural food components in the shrimp farming ecosystems. One is the development of phytoplankton and another one is the development of zooplankton, especially copepods. Shrimps majorly feeds on the copepods, but the copepod needs food, that is the phytoplankton. So these three also need to be present in our ecosystems. So development of phytoplankton, we recommend the application of dolomite because it contains the magnesium, and phytoplankton needs magnesium in their chlorophyll for the essential formation of shells and other pyramids. And the development of zooplankton includes the fermented rice bran application. Yes, rice bran need to be fermented, either it is via aerobic fermenter or it may be anaerobic fermenter. Aerobic fermentation includes rice bran, a probiotic, some salt, some agricultural lime, because once if you are using the probiotics such as lactic acid bacteria and other baseless, it will drop the pH In order to adjust the pH, we have to add the agricultural lag for 12 to 16 hours with aeration on. In case of anaerobic fermentation, we have to provide rice bran plus jaggery plus yeast, and we have to cover the entire system and it kept it undisturbed for 36 hours without any air holes. So that is anaerobic fermentation. What is the best strategy? Is aerobic fermentation suggested as it's involved a beneficial bacteria. So the beneficial bacterial count is also increases in the farm. So such beneficial bacteria will prevent the entry of pathogen bacteria into the system. And never use a urea or superphosphate or cow dung or vermicompost. Sometimes the pick manure, poultry manure, all parameters should never be used in aquaculture systems, especially swim farming, because they are the best carriers of the diseases to the swim. So based on only dolomite and rice bran, we can go for crops. You see, there is we have to rice and aerobic fermentation here.
Mr.
That is
Rajkumar?
anaerobic fermentation. I want to
Yeah, proceed. We lost your voice for last few seconds. You know, now we can hear you. You proceed.
Once all the once the water sorted, all the fertilization has been done, we have to go for the establishment of biosecurity. But biosecurity is only for the purpose of disease outbreaks and the spread control. This is a major essential element of the aquaculture system, especially shrimp farming. Even the government of India is also urging all the fish farmers and shrimp farmers to establish biosecurity. So what are all the biosecurity components? One is a bird fencing and crab fencing. The prevention of man and material. If the farmer is having 2 or 3 ponds, the material for the 3 ponds should be individual, because if the one pond is infected with the disease, if you are using the same material from the pond to another pond, the another pond will also get infections. It's nothing but a social distancing. So like the parameters we have to follow in such systems. The establishment of food tips and hand tips, or it's actually food tips, and the proper treatment of source water, as I already mentioned, sedimentation and disinfection, and the control of disease vectors such as the turtles, snakes, crabs, fishes, and leeches. We can kill them by organic chlorines or organic phosphates. So just move on. So you can see this is the bird fencing. This is the crab fencing to prevent the entry of crabs into the ponds, and this is the food tip containing bleaching or potassium permanganate for the disinfection of the ponds, not ponds, for the man and materials. If you are if you are moving the any materials from one place to another, we have to just disinfect the material and you can move to another sterile places. And there are some practices we are using some gunmen in the ponds. So the gunman will fire the gun when the birds are entering near to the farming areas. So such practices are also followed. Next, coming to the selection of food quality seeds. Yes, the seed is a basic input of aquaculture, because the 10% of the cost of production is based on this, but remaining 90% of the cost of production is based on this 10%. So this 10% is a basic input. So we have to have a much care on such seeds. So purchase of seeds only from the CA approved and reputed hatcheries. And we select only 10 PL10 to PL12, because lower PL stocking will also maybe also leads to a low loss, and the higher PL size will also not suitable for that. So ensure proper salinity acclimatization. Yes, because the hatcheries need to acclimatize the salinity of your pond water, because majority of hatcheries are establishing at 30 ppt of salinity. When your pond is having 10 ppt of salinity, or if your pond is having 4 ppt of salinity, you have to prior intimate your hatchery system to tell them, please acclimatize the seed to 4 ppt, please acclimatize the seed to 10 ppt. And you have to also check that whether the seed is at 4 ppt. So ensure proper salinity acclimatization. Majority of the freshwater farmers are failing in this aspect. So we need to have a more care on these things. And how to choose the healthy animals. Yes, the animal should be swimming actively, healthy, and not handicapped, and a low size variation. And Before packing, we have to test the PCR using external labs, at least 2 external labs at independent parties. Independently, we have to provide to the 2 labs, and they test for the AHP and white spot virus. AHP is a major component in mushroom farming, especially if the seed is not of good quality, there will be no growth, and it leads to some major consequences of economic. So sometimes recently more recommendations on IHMV and IMNV is also addressed, but we are most recommending AHP and white spot virus, and also pack in the same day of inspection. If you're going to the shrimp farm hatchery today, you ask the hatchery managers to pack today itself, and they never pack in new moon and full moon days because the animals may have some molding issues. So that time, if the animal is being transported to the from the hatchery to your farm area, there will be loss of mortality, and that maybe happens. So we don't recommend the stocking in full moon and new moon days, and never get trapped into the concept of bonus by hatcheries. There are some hatcheries with who are not achieving the targets are selling the low quality or substandard quality seeds to the farmers. So if the farmer is thinking that okay, 1+1 means 100% bonus. If 1 lakh seed is purchased, they will provide 2 lakh seeds. So the farmers may getting attracted by such discounts. So they are procuring from such hatcheries. So finally they will getting into the loss. So never be getting trapped into the trap of the bonuses. Be safe. Maximum bonus recommended is 30%. And this is the seeds, and this is the packing. The bagging bubbles, they are calling this bubbles. The precautions of stocking, even after the good quality of seed is purchased, majority of farmers are failing the aspect of how to stock in the pond in a proper way. Because the hatchery system environment is completely different, while the pond environment is completely different. If you are directly pouring the seed into the pond, the animal will be the stress. Sometimes it leads to the stocking mortality at the time of stocking. So first we have to keep the bubbles at least 20 to 30 minutes in the water in order to acclimatize between or in order to match the temperature, salinity, and the pH of the bubble water and the pond water. So after that, we can remove the animal into the ponds. So midnight stocking is recommended, and there is we recommend the establishment of survival hoppas. 1 meter into 1 meter size, a small hoppa is constructed within the pond. Around 100 PLs are stocked into that and left unfeeding. No, we should not feed the animals, and we have to wait for 72 hours and observe the survivals. Out of 100 animals, how much of animals is being survived? This gives the idea about how much may be the stocking mortality. So this is like this. We have to go for the acclimatization. We have to float the bag into sometimes into the pond, and we have to slowly releasing the animal into the pond. And this is a survival hopper. We have to establish some hopper and provide some animals. Wait for 72 hours without feeding, and again we have to recount the animals. If the recounting is more than 80%, okay, the quality is the animals are of good quality. If the counting is more or less, we have to think that our quality of the seed is somewhat substandard. The accurate feeding management, yes, the majority of farmers are failing in this aspect as well, because mainly in the brain feeding system. Because also the brain feeding is the easiest method, but the farmers are not aware how much easier it was. Plain feeding, the first 30 days, we don't know what is the size of the animal, so we are randomly feeding the animals. So overfeeding is not a general issue. Okay? Because there are the 2 types of feeding: overfeeding and underfeeding. Overfeeding means we are providing more than required, and in case of underfeeding, we are providing actual less than the required. So actually, overfeeding should not be done in mushroom farming. But in case of plain feeding, there is overfeeding is not a major issue, because we don't know what is actual survival in the farm. If you are providing underfeeding, there will be leads to the survival loss as well as size variation. Size variation means each animal will grow in a different sizes. So at the same time, the majority of farmers are not including the bonus seeds into their account. They are thinking that with they stocked in the 2 lakhs in the farm, but they forgot that the hatchery people added 10% or 20% bonus. So it means the farmer forgot to feed another 40,000 animals. So that also leads to size variation. So include the bonus seeds provide the adequate feeding, even overfeeding, no issues. So that leads to higher survival as well as the lower size weight. And the grower feeding after 30 days, we have to mandatorily follow the secondary observations. Here, the overfeeding will be problem because the overfeeding will lead to loss of water quality as well as economic loss because the kg of 1 kg of shrimp feed today cost around 85 rupees to 90 rupees. So even the 1 kg is wasted, you are wasting 90 rupees. So it is both economic cost to you as well as water quality cost to you. And the feeding must be increased or decreased purely based on the secondary observation. Yes, never feed the shrimp if it does not eat. If it doesn't eat, don't feed the animal. And skipping a meal or two, 1 meal or 2 meal is not a major problem. And a mandatory establishment of catwalk of hanging the sectors. Yes, some farmers are using some temporary provisions for hanging of sectors. That is not a good practice because sometimes some disturbances may lead to changes in the observation of sector. So the check tray should not be disturbed by any external parameters and it need to be hanged in a static position so that we can get the clear exact figure of what is the check tray observation. So after 30 days, it is a weekly sampling is mandatory for the adjustment of feeding. For what weekly sampling, we have to analyze what is the ABW we got. So like 2 grams per week, 1.5 grams per week, 3 grams per week, there will be some growth in actions. So based on that, we have to adjust the feeding. So weekly sampling is mandatory and also please ensure that the proper aeration is done to ensure the best feeding. If the aeration is less, the DO is less, the animal will be in distress. If the animal is in distress, the animal will not eat feed. So for every 250 kg of biomass, 1 HP of aeration is recommended. And the feed supplementation, yes, there are some feed supplementation we are recommending. Mixture of macro minerals, amino acids, and enzymes incorporation to the feed for the better growth and soft shell recovery, as well as the cut probiotics such as lactic acid bacillus and lactobacillus. So that will be helpful in the nutrient absorption as well as the digestive enzyme improvements. Organic acids, preventive medication for white fecal, and the immunostimulants such as vitamin C, microbial proteins to trigger the immune system options, and the fish feed attractants. Sometimes if the fishes are if the shrimps are not eating proper feed, we have to feed some.
Mr. Chandrasekar? Your mic is muted, Mr. Chandrasekar. Yeah, please proceed. Again, your mic got muted.
Yes,
Right. Yeah.
Yeah, this is a check tray provisions. You can see the feed is left, so we have to reduce the feed. Here the feed is completed, so we have to increase the feed. So if no proper feeding, you can see this animal is 40 grams, this animal is 4 grams. So such size variation may also occur. So and next is scheduling mineral application. Yes, there is one part is known as minerals and probiotics are the two eyes of the shrimp farming. Yes, because the inadequate mineral profile will lead to the damages such as low shell syndrome or running mortality syndrome and survival loss. So most commonly magnesium and potassium are used, and also there are some markets. There are some minerals such as macro and micro minerals combinations are available in the markets that yields a better results. And the frequency in case of low saline farmers, as already I mentioned, low salinity is having the problem with the mineral profile. So at least 7 days once. In case of high salinity farmers, 10 to 15 days once. Sometimes they are. It is not mandatory as the mineral profile is sometimes good. And application of minerals in the late evening is recommended because at late evening is having more low pH. Low pH is facilitates the dissolution of minerals in the water. So an application of minerals before a day before the anticipated molting, because molting in terms of molting, the the mineral will component will be most important to form the hard shell. Okay, so we have to provide mineral application a day before anticipated molting, such as the new moon day like Amavasya or Paurnami or Ashtami or Navami days. So never use minerals with disinfectants. So on the 13 is scheduling probiotics application. Yes, there are the two common probiotics, and the third one is there. That is a cut probiotic. But commonly we are using water probiotics and soil probiotics. Water probiotics is used for the establishment of beneficial bacterial community in water, as well as the control of ammonia and nitrate. As example, Bacillus. Bacillus are the beneficial bacteria which fight against the Vibrio, because Vibrio is a pathogenic bacteria. And Nitrosomonas or Nitrobacter are control of ammonia and nitrite. In case of soil probiotics, it will degrade the sludge accumulated in the bottom of the soil, so that bottom is stress free for the streams. Example, Rhodobacillus and Rhodococcus, and the frequency 10 to 15 days once or as required. Application with FRB. In case of the Bacillus is used, as we already discussed in the fertilization process, we can use along with FRB, because FRB is not only during the sorting of culture, we can use at any time in the middle of the culture. Application in the morning is recommended. In case of mineral, it is evening. In case of probiotics, it is morning, when the sunlight is available with aeration on. Probiotic application is not recommended on rainy days. At the same time, the probiotics and the disinfectants should not be used each together, because disinfectants are the antimicrobial that can kill both beneficial bacteria and pathogenic bacteria. So on culture maintenance of water quality, yes, for at least 7 to 10 days once, we have to test the water, such as the bacterial count, mineral profile, toxic components, and alkalinity analysis of alkalinity and pH. In case of control of Vibrio colonies, we have to use water probiotics or disinfectant. Water probiotics are what it is a biological control methods, and the disinfectants are chemical control methods. But it should never use both combinedly. We have to use either this one or this one. The control of ammonia, you can use equi extract, which is commonly used in the poultry industry. Ammonia oxidizing bacteria, as I already mentioned, Nitrosomonas and Nitrobacter, or sometimes zeolite. And as I already mentioned, zeolite is not working for the high saline ponds. Control of pH and alkalinity, agrelime is used for increasing. Water exchange is only for the decreasing. There is no other practical methods. Control of nitrite using sea salt or nitrite oxidizing bacteria. And the control of mineral profile, as I already mentioned, calcium chloride or magnesium chloride based on the our existing levels. Coming to therapeutics, when the prophylactics are best, there will be no need of therapeutics. But if the therapeutics, if the prophylactic, we are compromising prophylactics, we have to go for therapeutics. So therapeutics is not a major deal. Here, first slide, I am discussing major diseases. First one is a white spot disease. So there is no treatment so far. So we have to go for harvesting. So what are the recommended? Establish strong biosecurity to prevent the disease outbreaks. Even the white spot is affected. If you are observing white spots, we have to go for the PCR lab to test whether it's truly a white spot, because sometimes non-white spot induced white spot also happens, because it is a bacterial white spot. Sometimes the people are misunderstanding this as a white spot and going for harvest. So before going for harvest, go for the confirmatory test. And EHP, yes, it is a fungal pathogen. There is also no treatment. Harvesting is the best. Continue crop until the next count. So to the nearest count, you can go for the you can continue your crop, but don't continue the crop to the final extent, because as the EHP positive culture are proceeding, you are increasing the load of the soil. So you have to go for the higher treatment for the next crop. So seed is a major source of EHP, as I already discussed. Also, EHP is occurring in the soil if not treated properly. Yes. White fecal syndrome. This is a major devastating in the recent aquaculture trends. So first thing is go to water exchange, double dose the water probiotics and organic acid in the feed. Yes. Feed attractant in feed, and incorporation of vitamin C in the feed. So these all will help in control of white fecal virus, and keep the bottom clean by application of soil probiotics. Alternative way to probiotics. If you are not up for the probiotics, you can go for the disinfectants, but we are not recommending, because if sometimes we need the immediate results. So immediate results can be obtained only via the disinfectants, not via probiotics, because probiotics establishment takes 3 to 4 days. And after a week of white fecal treatment. If the animal is fell into the LSS, LSS means loose shell syndrome, we have to go for the mineral incorporation in the feed. And these all are minor issues. First three are major issues, and these all are minor issues. Minor issues includes Vibrios or LSS or blisters or hemorrhages. So this is also all are due to Vibrio. Vibrio is the most devastating pathogen, bacterial pathogen in the aquaculture, and it can be controlled. First three are they either fungal or viral or unknown pathogen, but they cannot be controlled, and we have to struggle more. But Vibrio is also pathogenic, but we can control via the pest practices, such as use of disinfectants such as BKC. BKC means benzyl alkanium chloride or triple salt, or usage of probiotics. If not a disinfectant is after, you can use for probiotics. And also you have to control the pH below 8.2 because pH below 8.2 is not comfortable for the Vibrio to survive. And the remarks common in high saline ponds in summer. Yes, it's a summer problem. And disinfectant and probiotics are antagonistic. As I already mentioned, these both are not good for the combinations. And white muscle syndrome, this is mainly due to DO problems, increase the aeration. Sometimes the black gill disease also leads to the white muscle disease because it blocks the DO availability to the muscles. And the black gill disease is due to unhygienic pond bottoms. Go for water exchange, go for good quality soil probiotics or BKC. Alternative treatment can be hydrogen peroxide and agrelime. Some people are from farmers are utilizing, but we recommend go for water exchange because the pond bottom is unhygienic. You have to go for water exchange and provide some soil probiotics. And muscle cramps. Muscle cramp is due to high temperature, escaping behavior of animals. If you are catching the animal try to escape from you. So that time the muscle there will be occurrence of cramp. So on mineral deficiency. So you have to increase the aeration as it is high temperature. You have to increase the aeration so that the temperature will be going down. Avoid frequent animal handling. Incorporate potassium in the feed. This is common in the shrimps less than 10 grams. So don't stock and don't do sampling in the sunny days because at high temperature, this muscle cramp is common, as I already mentioned. So running mortality syndrome, this is generally due to poor water quality, but what is the exact water quality is not so far detected. So we have to first identify the exact reason of RMS. So it is a major issue in the low saline aquaculture. When Vibrio is a high saline issue, it is a low saline issue. We have to go for a mineral application or the application of probiotics. We have to first understand what is the reason for the RMS, which water quality is compromised, so that we can adjust accordingly. Next is a parasite or zoothamium. You can go for the potassium permanganate or of 0.5 ppm or BKC. Or sometimes if the shell is more infected with the pathogens, you can go for the tea seed cake application because tea seed cake will induce the molting of animals so that the animal all the zoothamium will go out and the animal will generate a new shell. Sometimes hard shell will occurs if the animal is failed to molt because of excessive water hardness. We can go for EDD application. So this is a white spot syndrome virus. This is EHP. EHP cannot be detected. Only we can see is the size variation. And the animal is fecating with white fecal. And you can see this animal are reddish colored. So this is the vibriosis. And this is a blisters. This is also scratches. This is also due to vibriosis. This is a black gill disease. And this is running mortality. In case of running mortality, there will be no eyes, no legs, nothing. So the animal will, this carcasses will be like this. And this is a body cramp. The animal cannot be able to stand straightly, will always bent. And this is white muscle syndrome due to DO issues. So as a conclusion, water health plus soil health is equal to shrimp health, and shrimp health is equal to farmer's wealth. Yes, the farmer will become the crorepati. Thank you.
Thank you, Mr. Rajkumar Chandrasekar, for a detailed presentation. I will take up the questions from the participants now. In the meantime, can you please stop sharing the screen? Yeah. Can you on your video? So that Mr. Rajkumar, we can stop sharing the screen. You will have one red color button, stop sharing. Yeah. Okay. Thank you. The first question is, What is your job role at Eruvaka Technologies? Your mic is muted, Mr. Rajkumar. Yeah.
Yes, presently I am working as junior scientist for Aquaculture. It is a R&D department. So in R&D departments, we are working on auto feeders as well as the automatic devo machines. All the biological systems will be converted into technologies. So we are providing some data, and we are going for the surveys and give some input to the data collection teams, annotation teams, and the data technology teams, so that it can be utilized by them to develop the new technologies.
Okay. How did you get interested in farming of fish in pond?
Actually, my background is from fisheries only.
Okay. Okay. What is your education background, sir?
Bachelor of Fisheries.
Okay. Can you tell about yourself, sir? Can you tell about yourself, sir?
I am Rajkumar Chandrasekar. I got graduated from Fisheries College and Research Institute, Thuthukudi, Tamil Nadu, from 2020. This is my first career at Eruvaka Technologies at Vijayawada, Andhra Pradesh. And currently, I moved to Nellore, Andhra Pradesh for the field works.
Okay. How long you have been working here, sir?
It's around 2 years at Eruvaka Technologies.
Okay. Okay. We don't have any further questions. Thank you very much, sir. We have now completed the round of questions on behalf of agricultureinformation.com. I thank Mr. Rajkumar Chandrasekar for the talk and for answering the questions. I also like to thank all the participants in this meeting. This meeting will now be closed.